Hi guys, how are you doing? I'm pretty much the person that's keeping you from the partying, so I'll try to be as exciting as possible. So while we wait for my presentation to come in, which probably will, do you want me to help you? Cool, all right. I'll just talk random stuff. Who here knows why the Ethereum price is going up over the past 2 days? Raise of hands. Okay, if you're a male, you can raise other Ethereum prices. Okay, cool. Today, I'll be speaking here about decentralized software architectures. And this is normally confused with smart contract software architectures, which is a thing that I'm not necessarily going to be talking about. Because in my opinion, it's very important for us to start thinking like architects of decentralized systems and not just like an architects of smart contracts. Because if we think about the blockchain and any decentralized systems that we know of, they're not just smart contracts. Yes, they might have smart contracts as part of them, but they have peer-to-peer networks inside, they have cryptography, they have consensus algorithms, they have all these things in order to make them thick, in order to make them complete, in order to make them safe from all around the angles. And it's my opinion that actually thank you very much, for decentralized applications, it's very important for us to actually think from this perspective. Smart contracts are important. Having sound and fundamental, well-created, well-designed system is super important. And if we are now at the stage where DLT development, blockchain development is getting much more common than it used to be, which means that now there are a lot more people that are entering this space. And because there are a lot more people that are entering this space, they kind of need the blueprints, they kind of need the keys in order to be able to write software that's secure. They need the knowledge in order to be able to create systems that are secure. And how many of you here, let's do a show of hand again, has gone through formal training in computer science? Okay, a lot, cool. What are we taught in pretty much one of the first courses around architecture is design patterns. So what I want to try, and I'm literally going to be enumerating here because this content here has like, I don't know, it's maybe 40 of these or at least 20 of these. And I'm going to be highlighting them because if you get any one of these is worthy of a lecture and so on. So I'd much rather for me to highlight any of these, and you guys can know them, and you guys can actually, you can recognize them when you see this problem that you're trying to solve when you are actually building your application. And work? No? Okay, worked. Oh. Who am I? I forgot to tell you about this. Who am I? I'm George. I'm co-founder of LimeChain, and also, I guess more importantly for this lecture, I've been part of the architecture of more than 50 different decentralized systems over the last 5 years. And I have contributed to like at least 50 different projects in some capacity. It's whether it's coding, whether it's just architecting or advising of this. So I have kind of stumbled to all kinds of different problems in my journey in blockchain. So distributed ledger technologies, as I said, they pose a unique challenge and requirement in terms of the approaches and the problems that we are actually having when we are building decentralized applications. We need to try and make them pleasant to use. We need to try and make them cost effective. We need to make them secure and safe because people's livelihoods might be at stake, and we need to do this well. So we're going to be talking about design patterns. Just a quick recap, what's the design pattern? Design pattern is a reusable solution to a commonly occurring problem. So what I'll be describing over the next slides are what are the common problems that occur when you're designing software, decentralized software, and what are the reusable solutions that you can adapt to what you want to do. And again, I want to highlight this. I'm not going to necessarily be talking about smart contract design patterns. I'm going to be talking about decentralized systems as a whole. So let's get started. I'll talk about 4 groups of patterns. Scalability, how to make a system that when you add more users, it doesn't break your bank or technology. Security, how to not leave major loopholes in your system so that your system actually becomes exploited. Data input, how do you get the data that is needed in order for your processing, in order for your business logic to get executed. And user experience, how to actually make this technology usable for someone. And let's get started, I guess. Scalability stuff. First pattern, off-chain storage. What's the problem in here? A lot of you know it already. Well, it's if we try to store data on-chain, this costs money. If we try to store a lot of data, it costs a lot of money. So this is likely going to break the bank if somebody tries to store all their data on the blockchain. So what could be done for this? Well, the solution is to actually use just a proof of this data and not store the data in the blockchain, but actually to point this data in a layer that is actually storing this data. And there are multiple technologies that offer you this as a decentralized storage. Probably the most famous one is IPFS, but there are more like Arweave, like Filecoin. And you can actually just submit this data in this decentralized storage. And I'm overly simplifying this because when you start working with these decentralized storages, you're going to find their own problems. But having it oversimplified, if you submit the data there, then you can put a link to this data inside the smart contracts, inside the blockchain, and then you would have the data there without actually storing the data inside the chain. For the presentation purposes, I have added a quick diagram that outlines how all of this is going to work. I'm not going to go step by step, but later you can review the presentation. And also, I think this is the proper moment to plug in one more thing. All of this is part of a book that internally in LimeChain we created, and we are using as part of our knowledge sharing process. It's something that we want to share with all of you guys. So ideally, if you want to receive this book, and it's a book of all the design patterns that we're going to speak about here, that I'm going to talk about here, with much deeper explanations, and you can review the diagrams, and you can see examples of all of this. Just there is a LimeChain booth in the end of the hallway. Just go there. There is also a fun game that you can win Ledger. So go complete the fun game, and you'll get the book on email. So yeah, this was off-chain storage. Getting back into design patterns. Off-chain negotiation is the second pattern. It's a very interesting thing. It kind of exploded a couple of years ago. So now nobody talked about it, but actually exploded a couple of years ago. What's the problem in here? Every on-chain interaction, again, costs some form of money. And the more transactions that you do in your application, the more costly your application is going to be, which means that in the end of the day, either you or your users are going to pay more. So can we do with actually having less transactions, but still having the security that every interaction has happened? And actually, yes. I'll give an example of a marketplace where people might be negotiating over the price of an asset. Well, you can make every offer and counter offer of the negotiation process a part of the blockchain transaction, or you can let them negotiate off the chain by signing cryptographic messages and just put the final messages into the blockchain and let the blockchain validate that these are the final messages and exactly the people are doing what they're intending. This means that you can reduce all the negotiation process to a single transaction, or much less than all these transactions that are there. So yeah, this is the solution. You can design your architecture. You can design your smart contract in a way that you can submit cryptographic proofs of every step of the negotiation, the off-chain negotiation that is happening. By the way, this is the way that, for example, a popular NFT marketplaces work, like OpenSea. This is why you have free listings or nearly free listings of assets. This is the pattern that they use. Aggregate commit pattern is another scalability pattern. A A lot of DT-based applications need to use high speeds of off-chain systems while still maintaining the trustworthiness of the decentralized ledger. And current DLT applications don't offer quite the high enough speeds to cater to real-time high throughput applications that, or essentially their real-time data ends up being very costly in order to maintain. So what can you do? And we're getting into patterns that are later going to combine together, and we're going to see other patterns that are in here. Well, you can just use the aggregate commit pattern. It is fairly straightforward. It's exactly what its name says. You essentially aggregate the data in a phase, and then just put a fingerprint of this data inside the blockchain. This is the commit phase, and the fingerprint needs to be a data structure and to be cryptographically secure in a way that an end user or the blockchain, one of these, can actually verify that this is a valid data that has been aggregated and it has not been tampered with. Rollups. How many of you have heard about rollups? Cool. It's, in my opinion, very close. Like the aggregate commit pattern is very close in terms of thinking to what rollups are. Just it defines a little bit better what the aggregation phase is and what the commit phase is. So again, high transaction throughputs, much lower cost is what we need. And we can do this with a pattern called state channels that I have not included in the presentation, but you can see it in the book. But still, state channels are very limited into what they can do. They can enable just two people to talk with each other, much like the off-chain negotiations. However, for use cases where you need more than two people or you need to maintain state, well, this is now becoming something that's much harder to be done. So what you can do is you can do a rollup. So in a rollup, a participant can deposit funds or any other kind of value inside a smart contract, and then an off-chain system can start maintaining the state, whether this is their balances, whether this is their state in terms of memory that they're using and specific memory, the specific storage that they are using. And then certain actors keep aggregating this data and keep committing it into the blockchain. So this aggregate thing is called rolling up, and this is why the systems are called rollups. So generally speaking, there are two types of rollups. One is called optimistic rollup, and the ethos of optimistic rollups is I'm correct until proven otherwise, or I should be trusted until proven otherwise, which means that somebody can input, okay, this is the latest state of this off-chain network that I have aggregated and I'm committing, and you can trust what I'm being here, but you can also verify it, and if you can prove that I have lied, I'm going to get punished. And the other type of rollups are known as zero-knowledge rollups that essentially have the other way around. They have, they're using the ethos of you are guilty until proven otherwise, which means that you essentially need to create a proof and deposit it into the smart contracts when you are creating this aggregation. And the blockchain is actually going to be the one that is going to be checking whether everything that you have done off the chain is actually correct. So this, for me, is, by the way, one of the most exciting things that is post the merge that is going to happen fairly soon. I think it's in this month. For me, this is where a lot of the Ethereum work is going to go, which means that normally whole blockchain, programmable blockchain space follows suit. So probably this is a work, the rollups work is going to be something that we're going to be seeing more and more and more. So if you guys don't know enough and details about the rollups, I think it's good. Now is a good time for you to get into them. We talked about rollup types. You can see how all of this works. Like you have the rollup blocks, which are the generation of rollups, and then you have stuff like asking the blockchain to withdraw, and the blockchain is only going to allow you to withdraw your money out of this contract if you can prove that inside the the state that has been submitted outside of the system, you have the balance that you want to get. Next thing, again, scalability. And scalability, by the way, is the biggest part in here. So this is why we are getting a lot of work on this done. Team proxies. Well, a lot of times when we are designing smart contracts and when we are designing systems, we need to deploy one and the same smart contract over and over and over and over again. And at a certain point, it actually does not make sense for you to continue deploying one and the same smart contract, because this is actually quite costly, because you're deploying not only the smart contract storage, but also the logic. And you're doing this again and again, especially if your smart contract is quite big, then, well, it's problematic because you're paying a lot of money just for deployment. And what you can do is use something that's called team proxy pattern. And the team proxy pattern essentially allows you to deploy your business logic once and to create these very little thin smart contracts called team proxies and point them into the business logic that you are using. Yes, there are downsides to this, but essentially you're using something like, was it 50K gas in Ethereum for you to deploy another copy of the theme proxy, whereas your smart contract might be millions upon millions of gas easily, and you're essentially getting 20 to 50x advantages by using this. So again, scalability. Security patterns. Multi-approval pattern is probably the straightforward thing, the thing that everyone that is working in blockchain kind of knows about, because multi-sigs. So yeah, multi-approval pattern is the pattern where you can make a certain action in your application to only be executable if it is approved by multiple people. So again, multi-sigs, something that hopefully all of us are using or are planning to use for their projects. And yeah, normally it's a good idea for you to have some kind of a majority of majority of approvers to have approved before all of this goes through, because otherwise, if one of these people gets compromised, they might either stall a vote, or if just one is enough to approve certain action to go through, then if one approver gets malicious or gets hacked, then they're going to just essentially execute all the functions that they want. So going from the team proxies that we spoke about previously, there is another level that you can step up with the team proxies. What if you have your business logic put in the blockchain and you have your team proxies, but then you actually change where your business logic is and tell the team proxies, okay, this is your new business logic. So this is both good and bad. It's kind of philosophical issue whether this thing should exist. It's a thing called upgradability, because you essentially can upgrade the smart contracts. And this is normally something that when you go to the blockchain, you say, okay, smart contracts are never going to get upgraded, nothing is going to change, whatever you have written the first time, this is going to be there forever. And like the speaker before me said, well, we can be maxi, or you can be a total skeptic, or you can be in the between. I'm much like him, more in favor of being a maxi, but I'm not exactly a maxi. I'd like to be somewhere in this spectrum, but still have some opinions to be kept. Not completely like, not to be extreme. So I'm okay with upgradability. And with this pattern, what you can do, deploy a theme proxy, but enable the theme proxies to know that there is a new version of the business logic that they can oblige to, which means that if you have a bug, which for somebody that has been working for at least 5-6 years with software development in general, they'll know that bugs happen. There is no flawless software, despite that we want this to be true, but given enough time, likely every software is going to be put in under a condition and under state that they're going to perform faulty. So having the ability to actually change and remedy this problem could be a good idea. Then there is the other side of the philosophical coin that says, okay, if you can use the upgradability, changing the business logic for good, maybe you can also use it for bad, for malice. And yes, this is true. Upgradability is like the knife. You can use it to spread your butter on your toast, or you can use it to kill a man. So it is what it is. Use it in a way that's better for. Use it for butter. Another way of upgradability. This one is more tailored when you need bigger smart contracts, or your smart contract-based system is so big that you cannot fit it in a single smart contract. So diamond pattern is another design pattern that you can use, where you can separate your smart contract in a multiple smaller smart contracts and tie them together in something that's, for me, a little bit illogically, but it's the commonly used word is diamond. So you can combine them in a diamond. And the cool part about the diamonds is that you can actually cut, remove, and replace these parts of the logic. So you're again getting upgradability, and you can work around the problems of size limitations of smart contracts. Yeah, I told you that and that. Data input patterns, we're getting there. I know that all of us want to go party now. Oracle patterns, how many of you have heard about oracles? Last show of hands, so that we actually had some bodily fluids going. Oracles, well, oracles are essentially the way to get data inputted into the blockchain. Again, philosophical stuff. Are they good? Are they bad? You're kind of trusting external system to tell you something. So you're kind of introducing a systemic risk. On the other hand, if this is not the case, blockchains are always going to only live within themselves, which is not applicable in the real world. So oracles are systems that bring you data from outside, whether this is weather data, whether this is price data, or whatever it is what they do. So oracles, the solution is to create, Oracle solutions to essentially to create such systems, whether you're using publicly available service like Chainlink or API 3, or creating one yourself. Signature approval patterns. This is a lot of dApps essentially require for the user to enable, to approve, and to whitelist certain actions, or user to be performing certain actions. And every approval, as we spoke previously, like the off-chain negotiation, is one more transaction. So can we skip it and have a more optimal system? Yes, we can with signatures. So we are seeing a lot of the things that we did for scalability, we are actually can be start now using for data input or for security and all these things. So it's actually not that much. You just need to look at it from different perspective. So what you can do essentially ask one person to, one of the actors to submit their signature that indicates approval, give it to the other, and the other can be the one that submits both of their approvals into the chain, and the chain can actually verify that these are correct approvals. And this is, by the way, how many of you have used Gnosis Safe as a multi-sig? Okay, this is how it works. I guess you already know. For the rest of you that have not used Gnosis Safe, essentially this is what you do. You click some buttons that say approve, your MetaMask or whatever wallet that you have there, they pop up and they say, okay, just sign this. You're not sending any transaction when we're approving. Only the last person on your multisig needs to actually execute a transaction, and they are actually bringing all your approvals to the blockchain, and the blockchain actually verifies that you're all correct approvals and you have reached the majority that you have inputted. And last, user experience patterns, because user experience matters. Because we can build an amazing systems, and if they are not usable by users, well, we're not going to have users. So what we can do, first pattern is off-chain assistance. Whenever we need to query data from the blockchain, it might be costly or inefficient to essentially constantly be extracting large amounts of data. Sometimes it might actually even be impossible, because if you ask the smart contract receiver for the even for just reading data, but if you're asking them to perform calculations for them to give you this data, they might actually cut you off. This is not well enough known fact, but if you ask for big enough data on Ethereum node, even if this is just like a view function, they might decide to actually not respond to you. So a good idea is for you to maybe start tracking this in terms of user experience and be replicating the state of the blockchain yourself in a more traditional database so that you can actually quickly serve, filter, or query the data that's in the blockchain, while at the same time, anyone can see that this data is already in the blockchain. So yeah, you can maintain a partial or full copy of the data that is stored in the smart contracts, and then efficiently show it in the UI. A better version of this is known as the graph, which is a system that allows you to index smart contracts and things that are happening inside the smart contracts. And it's also decentralized, which is kind of this off-chain assistance, but made in a decentralized way. A lot, if not all, of the newest decentralized applications that are building on EVM-based networks are using the graph now. I think this is the last one, by the way, bear with me. Relayer. Many dApps require interactions to be done by users, but the users don't actually have incentives to do these interactions. So in the cases where you want to cover the costs for the users, or for any reasons you want to execute the action on behalf of the user, you can use this pattern known as Relayer, which is essentially a software system that you're building yourself that you can give to the user an access, and then they can request this software system to actually be submitting data on their behalf. You can combine this with the signature approval pattern so that this actually becomes also a smart contract secured system where the user can be giving the relayer certain information and the signature, and the smart contract is only going to execute this if signature matches. Which means that combining these two patterns, you can have a system where the user is not paying for transactions, for example, but also having a secure system. So yeah, pretty much this was my highlight of the design patterns. I hope that I didn't get you to sleep. I know that this is techy and geeky stuff, but I also think it's something that is very important because I'm passionate about architectures and I'm passionate about making scalable, secure systems. And I believe that anyone that is working and is developing and is engineering inside the blockchain space and inside the software system space should not only know how to write well and design well smart contracts, they should know how to write and design well software systems, because you might have the most flawless smart contracts and you can still fail as a system if your system is not secure enough. So yeah, any questions on any of the patterns? Again, I want to remind you that these are all much exhaustively written about in a book that we are circulating internally in LimeChain, and we want to give you access. Just go to the booth, which is in the corner, and just sign it up, and we'll just throw an email with the book to you. Questions? Any questions? We have time for questions. Yeah, I'm the last one. Okay, we can stay 2 more hours. Let's stay 2 more hours. What else we can do? A mic for you.
Thank you for the nice presentation. Very interesting.
Thank you for staying awake.
Okay. And as far as I see, most of these patterns exist to do some kind of limitations of the technology, let's say small block size or low transaction throughput. Do you think at some point this technology will evolve enough in order to do some of these patterns kind of redundant? And should it evolve to this point?
Amazing question. I can only speculate on this. My personal opinion is that many of these limitations, if we start thinking about them, they exist for a reason. And this reason is fundamental and underlying. Why do we have small blocks? Or why don't we actually increase the block sizes dramatically? We have examples of this. You probably know how this ends up. I don't want to mention any names of networks, but there are networks that actually increased this size, and then they had multiple problems, being down, all these things. So there is a limitation for a reason, and these are patterns and solutions to work around this limitation without actually trying and sacrificing other parts of the system. Then there are things that I don't think that ever going to change. So I can't see a blockchain system that is not based on DLT system that is not based on public-private key cryptography, which means that we always are going to have signing of transactions. It might be more opaque than it is now, but you would also kind of always need to implement the user experience patterns. So in my opinion, like 80 to 90% of these are going to stay for a long run.
Thanks.
As we can agree that, as you said, the blocks what we keep on ledger should be small as we can, but the querying this ledger is not very efficient. Sometimes you need to make much more sophisticated queries, which is extremely complicated. And do you see in this aspect GraphDBs as some solution to that, as they are some new way of relating data in triples? I'm not very into GraphDBs, but we are a bit exploring it because you can have links, predicates, and some very, very sophisticated complex objects and make very fast queries to it.
Yeah. Well, I haven't experimented with them myself, so I don't feel confident enough to be like an authority on this matter. What I can say is that when you say graph, in my opinion, always the graph comes in, and it kind of does what you say there because it indexes data and allows you to do a very complex indexing stuff. And this comes to, if you try to boil it down to fundamentals, it comes down to kind of this thing, the off-chain assistance thing. So you can use and graph
it's open
databases.
question, right?
Yeah, so the graph databases can be one way of doing this because your specific needs in your applications might be for data aggregation or specific data analysis. For other might be minimizing the state as much as possible, so you can use stuff like trees and optimized ways of storing data. So I haven't experimented with them myself, apart from using pretty much the graph on every project that is EVM based for the past 2 years.
Thank you.
Hi. What was the biggest challenges to create own blockchain?
What's that?
What was the biggest challenges to create own blockchain? Because I assume it's a LimeChain, so it's a blockchain, yeah? So you...
Yeah, no. We get that a lot, and also my favorite question is when Lime token. So likely never, because why would you need token? No, we are, LimeChain is a blockchain software development services company. We help others build their blockchains. So in this sense, if you ask me what are the biggest problems in terms of building blockchains, I can try and answer you this because we have done this with multiple of our clients. But LimeChain is not a blockchain itself, or yet, I guess.
Okay,
and
sorry.
it's not planned. But yeah, what are the problems? Choosing technology, finding enough other parties for you to actually decentralize network is normally a big one. So technological-wise, if we look at historically, in the beginning, most of the networks were forks of other networks. Then interesting technologies like Substrate by Polkadot came into being, and Cosmos, actually Cosmos was even before that, so Cosmos SDK came to be. Recently, Avalanche Subnet came to be. So you can use these to launch your own networks. And then now the problem becomes, how do you find enough other people that are willing to buy your token / coin and stake it, because normally they go for proof of stake these days, in order to make your system secure? And how do you find enough other parties so that you actually don't create a decentralized system that only has 3 nodes and all of them are run by you, which is, I guess, I'm not sure how decentralized this is. So technologically, problems are getting less, and I guess decentralization-wise problems are getting more now these days.
Yeah, thank you.
Cool. Anyone else awake? No? Cool. Thank you for the three of you that stayed awake. And for the rest of you, it's time to party. Bye.